mundane tasks that are out there, allowing people to perform a lot of the more the tasks that require a bit more detail to attention that some cleaning tasks can have.
Yeah, so profitability, risk mitigation is really the top line, the bottom line. Fewer injuries. Well, I read somewhere that in this $50 billion industry that is janitorial, about 12 billion of which is gone back to repairing people who get hurt from shoulder and back injuries. So if you were to think about 12 billion into 50 billion, that's almost dollar per dollar for the amount of money that the society is making in vacuuming and paying it back to repair our humans, people, in being able to function. So it's almost like vacuuming floor care is a loss leader. It's like buying a banana at a supermarket. They're never actually making any money on it. It just has to get done. So risk mitigation, fewer injuries, fewer lawsuits, less workers' comp, those are all reasons to consider automation from that tool.
And Xiao, people were asking actually, with regards to, since you did research in the industry, what's the total market size you could say for robotics and automation in our industry in general?
Well, so this gets to a little bit to what we can automate. The reason you're seeing a lot of the machines that you're seeing today, and Kevin will talk about a little bit later, is because of degrees of freedom. So if you think about a floor walking robot, it's really 2 degrees of freedom. You got the left leg, you got the right leg. It's reasonably easy to make. Every extra degree of freedom, if you think about a Mars rover, it's got 6 legs, and each leg has many joints, and the final wheel has a turning. So every one of them is an increased degree of freedom, and that just escalates cost. And so in order for a product to exist in this space, that's why I'm kind of breaking it down by light duty, floor care, and sanitation. And what we would likely encounter the most in this industry at the present time are floor caring machines. Does that answer your question? Okay, so maybe Kevin can talk about the next point of benefits of automation.
Yeah, so another benefit that we have here is the benefit of quality assurance. So with a person, it might not necessarily be consistency in the way they clean for like really long periods of time. They might say miss a spot, or in certain days they might be sick or have other needs to attend to. And with the benefit of a robot in the picture, there is a benefit of having more consistency in these cleans. The robot is is guaranteed to actually do the work. It would go and not accidentally miss certain spots, and even provide reports of where it cleaned in for certain machines.
Yeah, quality assurance. Just like when you step onto an aircraft, you expect to step out of it. When you hit print, you expect that sheet of paper to come out printing. That guarantee is what you should expect out of automation. If it does not do that job well, then we should revisit that particular piece of equipment, that particular service. Last thing is the scalability. As I mentioned, one of the gentlemen over here talked about scalability. So if we think about some of the steps involved in getting bids and then finding hands, well, finding hands are always hard. And it's not easy. I've interviewed many building service contractors who's been in the industry for 50 years. I've engaged with these professionals for 5 years. I've been building this business, and it's really hard to find labor. And this is why spooling up robotics, automation, and those types of equipment makes sense.
Question.
Yeah.
So how do you create the feedback or the pushback you give to
What is it, the purpose of the union is to be good for the people who are part of that union. If people are getting less sick and less injuries, I mean, we've been to conference rooms, not as big as this conference room, but people who come to work and they say they just get all sorts of asthma respiratory systems. We hear that a lot whenever we're demoing our machine, you know. If we have more vacuuming, they will have less asthma symptoms. That's why earlier in our slide, everybody's lives stand to rise. Not just the clients, but also the staff that's actually using it. And so, unions should be pro a piece of equipment that fundamentally elevates its membership. That's the mission of the union. So I thank you for bringing that up. And we'll talk about job types coming up. Yeah, it's a great question. So, but maybe before that, we can talk a little bit about how we got here.
Yeah, so the technology's really evolved over centuries, and it all began way back a long time ago when we were first dealing with farming. During the dawn of agriculture, we were advancing tools tools that help us become better farmers, harvest our crops better, manage our livestock better. And all these tools that really help us, similar to robots today, help us become more efficient, essentially better tools for our lifestyle. And that eventually leads us to the Industrial Revolution, in which these tools become more sophisticated through more advanced technology.
Yeah, absolutely. We don't need to go over each one of them one by one, but let's just take a quick survey, right? Thousands of years ago, humans discovered the relationship of the sun and the moon. And like if you look at some of the oldest, written down history, it's really humans invented the technology that is calendar. And when we knew calendar, we knew when to sow the seed and when to harvest. That's a piece of technology that transitioned us from being hunters and gatherers to agrarians. And then hundreds of years ago, we had the Industrial Revolution, right? That really said, okay, well, we can turn power on a shaft. And that really created, woven clothing or transportation devices such as trains and planes and automobiles. And then it became the electronics one, which is only not a few hundred years ago, but maybe half a century ago.
Yeah, and then from then on, after developing all those basic electronics, we eventually became more advanced with software in our computers. That's when things like those modern day programs on computers became more prevalent and more advanced. And today, like when we became more advanced with robots, we really extend beyond the boundaries of being confined within our computers and began to have more interactions with the physical world through hardware by the form of robots. And of course, in that sense, AI also plays a part into that. AI really helps these robots make decisions and know what to do and how to interact with our physical world.
I just got a question that someone gave to me. If robots are everywhere and all this AI technology is taking over, like what's the point of all of it? Who's going to do what job and what point are the robots going to serve?
Yeah, absolutely. So let's look at let's look at jobs. Jobs are what we all do. We know that human population has been climbing, but yet we have always been to find jobs. We can always be providing value, and each one of us are. And that's, in a way, the beautiful part about the work week is that we provide value to one another. Innovation changes jobs. As we've seen in the previous slide, we went from being farmers, like let's say 400 years ago. Most of us would be farmers. A couple hundred years ago, maybe a lot of us would be in factories. And presently, a lot of us are in service providers. We think about what is the pain of the other person, of the other client, and what can I do here? Let it be dispatch an email, pick up the phone, or changing a process that help one another better. And if we were to think about robotics as an industry, and this kind of gets back to the union question earlier as well, is that robotics also creates jobs. It's an industry, just like the aviation or the automotive industry, because let's think about what are the actionable things that a robotics industry needs. It needs manufacturing. Hardware. There's a piece of hardware that we decided to bring to Las Vegas to show it to you. and we can talk to you about every single nut and bolt. Not only are we manufacturing that thing, but we are also buying parts that other industry use. So there's manufacturing, there's designing of that machine, there's a service repair of it, which need to be at every location. There's assembling of that machine, and then ultimately there's customer service and marketing. So in the context of robotics and jobs and how we humans evolve in this world, while technology will keep on changing, so would we. We will keep on adapting and changing and making new jobs to make us grow further.
So yeah, there is definitely a concern that robots might take away our jobs. As some of you have mentioned, that there are some pushbacks from unions and all these people. But ultimately, as Xiao mentioned, we believe that robots are really here to create jobs rather than to take away. They are really more, we can think of them as companions. These are really tools that help us become more efficient in our jobs. And as an example, consider this one company we have here. It's called Dusty Robotics. And like many other robots out there, when these robots were first introduced to their clients, there was a lot of pushback, and there was fear that these robots would take away the jobs. And these robots, by the way, their purpose was to go around these construction sites and draw lines on the ground for the purposes of determining where things need to be placed or built on these sites. And yeah, there were definitely a lot of fear of these robots taking away a job, but eventually, over time, these workers they found out, well, these workers had really many tasks within their jobs that they need to do, and this robot was really only taking away or doing the long and tedious parts of their job, that one task, which allowed them to do the many other tasks that were on their to-do list throughout their day.
Hey Kevin, we got a question here actually.
Yep.
If you don't mind me jumping in.
What's the average runtime of your equipment in actual equipment versus floor space? Is it small, too small, too large?
Yeah, so the actual runtime, I guess it would depend on the robot. Some are big, some are small. The robot that we have, it runs about at least 7 to 8 hours. At least that time, that's when we clock it in, so it can at least go for that long. As for other robots, that is so many robots out there. It's kind of hard to keep track of how long all these rows. Maybe Xiao, you might have more insight on this.
Yeah, just to be more specific, one should consider a number of square foot. So is it 5,000 square feet? Is it 2,000 square feet? Client geometry plays a big role. Let's say we push all these chairs in right now, and you're to deploy a machine, right? This is one type of configuration. If we had theater seating, that would be a different kind of configuration. And it depends on if that robot can fit into that space. If it's, when we've done studies about office space, it's a lot slower. When we do stuff like open hallway, maybe 5,000 square feet, 4,800 square feet, when we're in very tight corners in and out of office spaces, maybe 2,500 square feet to the hour. And the runtime is still the same. Ours is about 8 hours, a lot of other vehicles about 4 hours. So a lot of times people like to cook up these numbers. Be sure you ask them about the scenario, and we'll talk about that in a little bit as well. Our machine's about an hour to hour, so these things are designed to kind of say you're able to do, half a day to a full day worth of work, and then you can set it and charge it and come back again. Is that cool? All right. So as Kevin has talked about, will robots take our job? Well, it's really just shifting jobs. And now let's get back into something that we in this conference are a little more familiar with. It's just facility maintenance tasks. in facility maintenance tasks, it really makes sense to automate because facility maintenance is such a physical industry. There's a lot of hands-on work. One's got to actually go pick up the piece of paper, the pencil, and put back the chairs, empty the trash, wipe things down. So there are never enough hours to feel that work. That's what it feels like whenever we're interviewing people. People are always fighting fires, running from one place to another because one person was sick and so on and so forth. And so what we have learned over the last 5 years is that there are two types of work. They're the more repetitive work, which just means that it's a guaranteed outcome. If I were to vacuum this floor right here, the guaranteed outcome is that I vacuum every square inch and it is done. It is clean. And then there's other stuff that are more unexpected and reactive, and that requires a little more thinking, a little more pulling processes together. Maybe there's an extra stain on the ground, maybe there's some extra situation that occurred that require human attention to send that energy to.
So Xiao, I'll jump in right there. Somebody just asked if we can just get to the point of what's something a robot can just do. Since we've heard a lot about general robotics, we just want to know what's some of the tasks they can do right now.
Okay, then I invite us to check out the next slide, which are some of the robots that are already out there and doing that work. Do you want to take the first segment?
Yeah, so in terms of, there are definitely lots of robots out here that have lots of applications. So, well, first of all, some of you guys might have seen consumer-grade robots perhaps in your home. Like, for example, a Roomba. Like, how many of you guys have seen a Roomba in your home or know someone with one? Cool, nice. Yeah, and there's also, we consider like Siri and Alexa, these sort of like robots. Well, while they're technically not robots, they can't interact with the physical world, they have also capabilities to make decisions, which is sort of some of a backbone to a lot of these robots as well. But to talk about commercial, the ones that do commercial work, we have various categories, one of which is the military and government. And these kind of things are, they might be somewhat involved in direct defense, like for example preventing drone attacks or disposing of explosives or mining the oceans. Some might also have some help in fighting fires or handling crates that are delivered through the seaports, or even trucks that drive themselves to assist with mining, or even robots that go far out into space to explore places like Mars.
Yes, I got maybe we got a question over there, but until that question, yes, we've seen that. We know that the government trusts robotics and automation. We know that our food suppliers are also using automation. Fruit and vegetables are being picked, harvested, and seeded by robotics. Self-driving tractors and harvesters are present. There are like apple picking robots out there. And one of the more recent interesting ones that I heard was to use a drone to spread ladybugs, because it's actually very infeasible to go plant ladybugs in a large field, but with the aid of robotics and drones that we're able to use a more natural way of doing agriculture. So these are some of the ideas, and I don't want to get too much into this, but in other ways, private sector power line inspection, so where we are, Pacific Gas and Electricity, they have a lot of power lines, and that we use robots to assess. Warehouse fulfillment, anybody who's had an Amazon package, very good chance that was handled by robots. The supplier that we use for all our hardware, Kimball Midwest, all their nuts and bolts, all made right here in America. And they tried one robot for their warehousing facility, and they had such great returns, 30% increase in profitability and 30% increase in productivity, that they ended up getting like 31 machines for their warehouse. And we found out about this because we are a client of theirs. So these are just some of the areas that robots are being used right now and helping out. Construction, earth moving, as I mentioned, site drawing, security patrol of malls, healthcare, two of the hospitals that I went to recently, they have medicine delivering robots, so as to reduce the nurse's time in delivering the medication and food. And then, last one I have mobile rehabilitation, that's another one that I actually worked on personally. I worked on these human-worn exoskeletons that are there to design to help people with paraplegia to walk again. So that's another space that robotics are being used. And lawn care, if you're an avid golfer, maybe you've seen these things being roamed around.
So Xiao, one, we can read, so you don't need to read everything off. But two, we kind of want to know what you do for a service, because it's not totally obvious what kind of robot we provide here. So one, give a brief of like what our robot actually does specifically, and two, do you have any case studies or examples to show we've done our job successfully in any situation?
Yeah, well, our robot is floor care. We do 5,000 square feet of vacuuming for 8 hours, continuous. We know it picks up a lot of hair and dander. We know you can pick up, we can get to within inches of an edge. We know it picks up a broken cup, and so yeah, so that's what our machine does. Does that answer your question? Okay.
Sounds like.
All right. Do you want to do the next slide, Kevin?
All right, so yeah, with all those different applications of robots that we've seen I guess it's getting to like the ones who we probably care most about, which is the ones that deal with facility maintenance, particularly the ones that clean commercially for us. And yeah, there are many different types of robots that clean for us. And some might include various types of mopping, some that do vacuuming like us, and some that might sweep facilities, clean bathrooms, wash windows, sweep the parking lot, and some that might do disinfecting as well. Disinfecting ones, they were especially popular during the times when COVID's really started to become more rampant and all those lockdowns and stuff. And they were able to go around and clean, disinfect surfaces that many people seem to deem unsafe for people to really touch for extended periods of time. But anyway, whatever robots you actually end up using, the main idea here is that while the robot is doing all this work, custodians will be able to focus on the more higher priority and those reactive tasks that we previously mentioned, those tasks that require more attention to detail.
Awesome. Yeah, so earlier there was a question about exactly how our robot works, and here's a case study. So here's a 30,000 square foot place that was paying us to clean, and it's a co-working space, 80% carpet, lots of foot traffic, open layout. And what we saw before the deployment of autonomous vacuum was that there's backpack vacuuming, spot vacuuming for most of the area except for the front entryway. There's always seems to be like uncertain availability. Sometimes the 2 people team that will come, only 1 person will be able to come, but they still have to rush off to the next job. So we eat there, we use the space. This is where we developed the robot. And so after we were able to get the robot in there to use it, the robot vacuum basically does wall-to-wall vacuuming at the press of a button. I monitor it from 120 miles away. It pretty much it looks like Pac-Man. It just vacuums, it's full coverage, it's very consistent, it's very repeatable, and every time at the end of it, you can see, like, again, imagine if these rounds are the case, and you were to all push in our chairs, and you were to hit a button, the vehicle would just mow this entire area around and do all it needs, and you just have this sheet of paper with all the green area for where it's vacuumed and white circles for where it's not vacuuming. That's essentially the result that we offer. And being as we were responsible for cleaning it up, we see so much dog hair, so much dander, just so much stuff and gunk. I mean, I bet you were to vacuum with a clean machine out there for like half an hour on these kind of carpet, you'll pull stuff up. And so that's how we have designed our machine. And it only took an hour. No matter what, this thing just took an hour. So that's what our machine did, and that's what we noticed. We noticed that the less gray on the carpet, sharper contrast, the black is blacker, the light color on the carpet is lighter, and those are some of the stuff that folks said to me when we were at this place.
Xiao, we just want to know, one of the questions that was brought up is, with regards to how we go to pay for this robot, so a lot of robots are expensive. We talked to somebody outside, $60,000 for just one of the robots.
Mm-hmm.
How's it compared to us? How do we go and mitigate like maintenance on this thing? Because it can cost thousands of dollars per month just to go maintain this robot. Is it on you? Is it on us?
Mm.
And how does it compare to competitors?
Yeah.
Even for lease or renting the robots?
And I think I get another question over there. But as you're getting that question, it's a great way to segue into this particular slide. Do you want to take this one, or do you want to take the next one?
So yeah, there's I guess the whole thing about like buying versus leasing a robot. So some of you might be wondering like, well, why do I want to like pay those recurring fees in leasing a robot when I can just buy it outright, just pay it one time and just own it and do whatever I want with it. Well, the thing is that like these robots nowadays they might not necessarily be a perfect machine. So you might find yourselves having to do some repairs or maintenance to them. So you might have to consider, well, who owns repair? Like when something breaks down, how are you going to find replacement parts? Or how are you going to actually repair the robot yourself? Well, in some cases, it might be difficult, it might be easy, but either way, that's going to take some time, like out of your hands. You gotta fix and maintain these machines when you could be actually using the machine to actually perform the actual cleaning work that you wanted to do in the first place. Now, on the other hand, when you lease a robot, well, you end up having more supports and upgrades that come with that experience. So there will be a team that goes around and maintains the robots and make sure it's actually in a usable condition by the time you want to use it. So when you actually want to do a cleaning job, you go ahead and actually use it rather than figure out how to troubleshoot so-and-so or set it up and things like that. So that's basically one of the main things considered, one of the differences between buying and leasing that we have here.
I think it really depends on, I think it's leasing. I mean, we've been invited by Paul and ISSA to speak here, and so I don't necessarily want to be very self-promoting. We try to be very objective in what we present. A lot of times people want that buying option, and so a lot of people are selling the buying option. But in reality, they say, oh, okay, well, then you gotta buy this maintenance contract. Okay, how long is that lasting? Oh, 36 months. Well, what's gonna happen after 36 months? Oh, the battery's gonna go dead. Well, it's not it's not a battery for a Tundra or anything. Where are you gonna get this battery? If a LiDAR goes dead, where are you gonna get a LiDAR? When something is in your wheelhouse of knowledge, you should buy it. When something's not in your wheelhouse of knowledge, pay for the service. That's honestly what I think. I'm sorry? I can't quite hear that question, but maybe Zach can help with that. What is AGM? Oh, like plugged in kind of vehicle? Yeah, the power aspect of it. The battery is one example, if I understood your question right. The battery is one component of that entire device. I've interviewed janitorial service providers who own 300 vacuums, and they said that they have one person that's dedicated on their team just to keep vacuums working. And so what is it? Motor brushes, extension cables, replacing the filters. Now imagine doing that type of work, but on an autonomous piece of machinery, which really good 85% of which is in the software. Like, having worked at Apple for 5 years, the code stack is really, really thick. And we're asking this thing to be out there. It's almost like a lunar lander kind of a thing. I mean, you'll get the thing done, but like the intricacies of getting it done every day very consistently can be up there.
And Shao, I've had a few people raise their hands to ask me questions, so to expedite this, since we have about 15 minutes left, I'm going to go and introduce Elizabeth Marshall, who's in the back right there, who's on our team. And we're actually going to go jump ahead and let you finish up the last bit right here. And then we're going to jump in and let the crowd ask some questions, since many of them are curious more about the specifics of our team, our knowledge, and also how the robot works exactly. And I can see a lot of people who are just sort of ready to jump on and ask some questions sort of very specific. So I think I might want to get to that portion just since a lot of people are curious.
So curious about our robot rather than like our whole like how robots influence facility maintenance. Is that what you're saying, Zach?
Oh yeah.
Okay. Well, maybe I can just go through this slide and talk about how you can engage with a robot service provider, and then we just open it up to the floor, because this is pretty much towards the end. So we suggest that you take your time. Take your time with this robot service provider. Don't just trust whatever's on the brochure, or because then you kind of like you're imagining things, and the thing with imagined versus what the reality is, especially when it comes to a piece of software, can be a huge gap, right? Especially when it comes to robotics where you want it to actually work. So you intro, you say, okay, well, site walkthrough. Does this facility benefit from a robot? What kind of robot? Is it our robot that's 2 feet wide, 2.5 feet long, or is it something smaller, maybe a 70-pound robot? We call ours the 170-pound weight class, or do you need a 300-pound robot? What does your site actually need? And then you want to see a demo of the machine. Okay, bring the machine here, do a piece of vacuuming, put some dirt in front of it, see if he picks it up. Is it one pass? Is it 2 pass? Do you need to deploy it for multiple passes? So you're gonna have a better and better idea. And then we say, engage with a trial. Engage with a week-long or a month-long trial. For us, any place, we'll figure it out within a week. But maybe for others, it takes about a month to get the full ROI, to know what to do with the different staffing hours. So really get those, answered first. I saw your hand. And then the last thing is that you can engage with a long-term trial, because with robotics, your configuration could change. Your clients might have a different kind of wall setup. You may end up having to move the robot to a different site. Who's going to support all that stuff? So those are all the very important questions when you're assessing a robot service provider. So we got a question over here and a question over there, and I promote the idea that we kind of switch gears and make it more talking about what people want to talk about. We've got 15 more minutes.
One initial question someone had over on that side of the room was, is your robot made all in-house, or are you using parts from other companies, other software from other companies, or is this just your own proprietary system, both hardware and software?
That's a very interesting and detailed question about our robot. So the thing that I'm particularly proud about our robot, this thing is literally a project that came out from my garage, because I said, well, it makes business sense to have self-driving technology used in facility maintenance. I actually interviewed the person who invented iRobot, Rodney Brooks, not too long ago, and I interviewed other people who made Anito Robotics, which is another robot. I'm like, you can't create this robot vacuum. Why are you creating a larger size of it? Well, they're just not interested. Well, I'm interested because I think it's a great reason for it, and so I literally built it with other people. So we do have some software that's licensed out, but we own just about all of it. We build it all in-house. And I think it's great to have a very vertically integrated product, from user interface to hardware to service, because you understand the whole chain. So when the client gets what you get exactly what I said you get, instead of a lot of uncertainty. Does that answer that question?
Yeah, I'd say it does.
All right. I thought there was 2 questions. Yeah.
Oh, there we go.
So can you tell us about your robot? How does it work? You have sensors with it, recognize when someone walks in front of it, does it have anything about drop off, sensor, and give me some details of how your product can work around the program?
The question is, what's our robot? What's special about it? The specs of it? How's it work? How can it integrate in your facility?
Yeah, so in terms of what's actually on a robot, so we have some cameras, one front and one back, as well as a LiDAR instead of on top, which is basically kind of like a laser version of a radar that allows it to scan and see things all around it. And in terms of the clip drop-off, it doesn't actually, it currently doesn't have one. But we currently try to deploy our robot in places where it's not actually near like any places where it could potentially fall off stairs or off a ledge or things like that.
Yeah, the way that no matter what you're looking at, whichever product, the fundamental technology is all about the same. There are two pieces. One is a LiDAR, which you know how you can go to Home Depot, you can get one of those laser rangefinders. That's essentially what it is, except he spins it around, and so he kind of has these like laser tentacles of where it is. That's fundamentally his range distance measurement, is how he knows where everything else is, because it can measure the size of the room, and you can say, oh, here's a round table, here's this corner, and it's similar to that corner. That's one part of technology. The second part of technology is really like, you know how you have your mouse, the optical mouse? Anybody have an optical mouse? You have a little piece of laser. So the little piece of laser just shines onto the surface material, let's say your jacket or tabletop, and it bounces up, and there's a tiny little machine vision processor to say if you're moving forward or moving to the right. That's all there is to a mouse. For these robots right now, the reason they still need a lot of setup is that they don't understand, I'm in a room that's divided, I'm in a room with this kind of molding and so on and so forth. It doesn't have that semantic understanding of chairs or tables. It just says, I see some beige over here, I see the red from the exit sign, and that's next to this brown door. I must then be here if I'm looking at that view. But it doesn't actually understand that it's staring at exit signs or tables. And so that's a fundamental way for these robots to localize where it is and then to navigate. The way that it detects not to hit anything is essentially when it's running real time, it's got a pair of stereo vision cameras that's, again, it's able to it's one of those Magic Eye posters, you know? You know what I'm talking about? Right, when you get Magic Eye on the robot, it's able to see 3D and it says, oh, there's a person here, as opposed to there's a picture of a person on the ground. And that's essentially how he disambiguates where it can go. So for the question of how does it fall off a cliff, I don't even understand how they could program a thing to allow it to fall off a cliff, because why would you program a thing to go to a place where it does not know how to go? So I think that's an implementation error, not a sensing or some kind of profound technology or anything.
Now, Xiao, there's a few distributors in the room that came and asked me this question. I've heard it about 10 times now. So how does this robot compare in regards to ROI? So if I have to pay a worker $15 an hour, how does this robot compare with regards to cost savings, and how much can I really make at the end of the day if I want to switch to you?
I feel that the ROI question, it comes down to, you should be able to expect to pay half as much for the work that you were using to employ humans to do it. I think that's a very fair starting point. And what I mean by that is technology will evolve and change. Imagine the very first portable telephone that you've ever seen in your life. I remember this, 90s Lexus that had this whole headset thing that was in the back, right? And the cost of that piece of good is insanely high. Over time, decades, a lot of effort, everybody has a smartphone and a cell phone. That's how I sort of see these things are. But the reason that we're here and talking about this right now is because all this self-driving technology has come to a point where a piece of product can be made and it can be marketed and made money cheaper than it costs to develop it, or else that would have never happened. And as it stands, in the 90s, I remember interviewing a company, they were charging $90,000 for a piece of vacuuming equipment. The technology is not there to do it. Right now, I would say you should be able to buy a piece of equipment and expect to pay half as much in getting the same value out of it than if you were to ask a person to do that exact scope of work. Does that make sense?
No.
That's my expectation, and that should be your expectation. If that's not your expectation, then it's becoming maybe politics or something. High risk. Yes.
So what type of environments are not a good fit?
It's really on the mobility side of things. If it's too small of a place. The robots right now that we're looking at is still kind of like how I was describing what the robot sees and what he perceives. It's not as nimble. So if it's a very small place, like a very small school facility or a bank or those kind of venues, it doesn't have that scalability. Robots are better at like just going down the hall for 5 straight minutes, turning around and coming back for 5 straight minutes and doing one more pass, which we've done. That one, humans don't outwork, robots don't, humans don't outwork robots. So I would, that's why the site walkthrough is very important and figure out what type of machine is offered by the vendor and does it fit your particular space. Does that answer your question? Yeah. Cool. Any more questions?
One question was about resiliency. So if there was a disaster, let's say at my site, an earthquake happened, or a flood happened, could my machine notify me, let me know there's a flood? Please do something about it. An earthquake, let me know. And at the same time, can I teleoperate the robots from, let's say I'm sitting in the Bahamas on a beach and I want to control the robot. Can I go and do that? How does that whole process work with regard to your system?
So teleoperation and what was the first question? Because I think
Teleoperation and also emergency situations. So it'll notify me how is it able to detect any of those issues.
Yeah, so I guess in emergency situations, like a lot of robots, including our own, they have an emergency stop button, which when you press that button, it would immediately stop the robot. But these kind of situations are, I guess, mostly kind of rare, and like we will only really need to press them that button in only case like someone, like say, runs in front of it in a weird way. And in terms of teleoperation, yeah, so I guess currently on our robot, so we currently teleoperate our robots with our phone or anywhere that has access to an internet browser. So it's basically a web app. Yeah, that's the way we do it. A lot of other robot providers out there, they might have different ways of having that user interface, but yeah, for us, it's a web-based interface for that. And while for us, while we're actually teleoperating the robot, it currently doesn't have like a way of like detecting obstacles in that state, and it may need to be up to discretion of what the user, the person who's driving it, whether how safe they choose to operate the robots. And yeah, but when it's the robot is fully in autonomous mode, that's when the actual obstacle detection and all those obstacle avoidance and stuff, that's when it kicks in.
Yeah, so just to make sure we're on the same page, first of all, for safety, if there's a flood, we have a lot of fuses on the thing. So if anything, the robot is a thing where you'll keep going, and if there's anything that's abnormal, if it's like the space is too tight or something bumps into it, it'll just stop, right? That's typically how we mitigate emergency, if the flood question was to that. And in terms of a remote operation, yes, it's definitely something that you can monitor and maneuver from. I've done it from 120 miles away, as long as you do the Wi-Fi to the machine. So yeah, one could oversee all these machines. You can see the front camera, back camera, LiDAR, everything you want. I do want to finish with a couple of slides that we felt that was very important in terms of robotics, automation, AI, and facility maintenance, because it really gets into the heart of why we developed this product. So 8 hours in a typical day. There's never seems to be enough time to provide that extra sense of care, because there seems to be such a sense of urgency to just be able to get this stuff done. And we feel robotics offer us to provide more care, because we can be detectives. We can service that person better in ways that we can say, okay, we can either use a piece of automation equipment or we can change our process. And we feel like those are the areas for which robotics and automation offers us a moment to reflect and to think. And at the risk of drawing these analogies, if we think about Renaissance and think about humans going from hunters and gatherers to agrarians, we were given the liberty to have some part of the population become, Shakespeare, thinkers, right? And we get to have play, and we get to, talk about, reference, a psychological situation towards a play. And that kind of stuff is enabled because we have the, privilege and the freedom to think and do more stuff. And that's what, I feel like human advancement is all about. You want to finish the last slide?
Here's a question.
Oh, yeah, question?
Last slide, and then they're going to get to you.
Okay, yeah, but ultimately, one of the main ideas we want to, really address here is that, with all these robotics and automation tools out there, they really help us provide care to both our facilities and to our employees, basically by offloading these long tasks of cleaning that involve long amounts of time. We can prevent injuries and all these that would be hazardous to people, essentially. And they will also better the facility as well in having more cleaning done as well. So we can think of basically having a robot ultimately as an investment for people, your facility as well. Having more automated ways to do things really contributes to more care.
Cool. Well, 1:59 by this clock, so.
Now 4 o'clock?
or 4 o'clock. Yeah, sorry. This is 1:59 over here, and it's very close to 4:30 right now. So yeah, that's us. That's Friendly Robots Company. All of us present. We thank all of you for spending the time. And we thank ISSA for inviting us over here. We'll be here to answer questions, and we'll be outside with the robot. So, thank you all so much for your time.
Thank you. There's the robot outside. I want to see it. Can we go? I'll be outside. Joseph, come. Hello. Hi. Yeah. So,
how much this round before it is localized, how much this round, and that's why the price is